Hello students, good morning. Today we are going to learn a new chapter, that is chapter number 13 of 12th class, AC circuit. AC means alternating current. In the last chapter, that is electromagnetic induction, we have already discussed about the alternating current. Alternating current means or AC current. There are two types of current, AC current and DC current. AC means alternating current, DC means direct current. In the last chapter, we must recall some points of last chapter because this chapter is depends upon the last chapter, some point of last chapter. That is, we must know about the Lenz's law and the EMF induced in the coil, that is self-induction, mutual induction, or induced EMF and then induced current. Then we learn about the AC generator and the generation of AC current in the generator. Now, in this chapter we will discuss about the AC circuits. Before going to discuss about the different points in this chapter, we must know what is the difference between the AC current and DC current, or AC supply and DC supply. In our domestic use, we always, or in our domestic appliances, or for our electronics devices, we always use the AC supply. आपल्याकडे घरी किंवा ऑफिसमध्ये जो सप्लाय यूज केला जातो तो एसी सप्लाय राहतो. तर जनरली आपल्याला आपण एसी सप्लाय काय यूज करतो? इट इज इझी टू पोर्टेबल अँड ऑल्सो इट इज द कॉस्ट ऑफ एसी इज रिजनेबल दॅन दॅट ऑफ द डीसी. हियर AC current, it means the alternating current. In this alternating current, the value of current goes from 0 to high value and then again high value to low value up to 0 and then negative value of current, that is high negative value and then again 0. In one cycle of AC current, we can observe the 0 value to high value. That is, current changes continuously with respect to time. But in DC current, that is, the current is steady, that is, the current is constant. Or we can say that in DC supply, the polarity of supply remains constant. When we provide a DC supply to any component, this is the symbol of DC supply, or we can say this is symbol of cell or battery. When we use the DC supply, we use this symbol, and when we use AC supply, we use this type of symbol. This is the symbol of AC supply or AC EMF for our EMF of AC supply, and this is the symbol of EMF of DC supply. Now, DC is direct current which has a fixed polarity of voltage. The positive and negative ends, these positive and negative ends are fixed in this DC supply. But in case of AC supply, the polarity continuously changes, and therefore we call it as a alternating current or alternating supply. Polarity of voltage keeps changing periodically. We have already discussed about the AC voltage or generation of AC voltage and about the AC current. आपल्या घरी काही वस्तू असतात. सपोज या ठिकाणी टीव्ही आहे, कम्प्युटर आहे. तर त्या टीव्ही आणि कम्प्युटर हे AC करंटला DC करंटमध्ये कन्वर्ट करतात किंवा त्या ठिकाणी एक प्रकारचं इन्स्ट्रुमेंट त्याच्यामध्ये यूज केलेलं असतं जेणेकरून की AC करंट हा DC करंटमध्ये या ठिकाणी कन्वर्ट केला जातो आणि हे जे वस्तू आहेत त्या DC करंटवरती वर्क होतात. दॅट इज सम objects were some the DC current that converts the AC current into DC current. But in our home there are some devices like fan, fridge, air conditioner, heater, induction heater or coil heater which runs directly on AC. Directly on AC. या ठिकाणी काही वस्तू असतात ज्या की डायरेक्टली AC वर वर्क करू शकतात. फ्रीज, फॅन, एअर कंडिशनर, हीटर हे डायरेक्ट AC वरती वर्क करतात. परंतु काही वस्तू आहेत इलेक्ट्रॉनिक्स डिव्हाइसेस आहेत जसे की टीव्ही, कम्प्युटर, ट्रान्झिस्टर, रेडिओ. These devices convert AC current into DC current by using the rectifier. त्याच्यामध्ये रेक्टिफायर बिल्ट केलेला असतो जेणेकरून की AC करंटला आपण DC करंटमध्ये कन्वर्ट करू शकतो. Now we will discuss about the graphical representation of AC current. We know that the AC current varies with respect to time. That is the value of current and the value of EMF varies from 0 to high value, and we get this type of graph. We have already discussed about this graph. This is the maximum value of EMF induced. That is, that maximum value is called as E naught. This is the positive E naught, and this is the maximum value in the negative region. That is minus E naught. For one cycle, the phase difference can be right here, or we can use a time period also here. This is the complete time T for one cycle. Then this will be T by 2. This will be T by 4, and this will be the time period of 3T by 4. When we take the phase difference, this graph, then we can represent this as a 2 pi, that is for one cycle the angle will be equal to omega t. When we take a graph in between the phase difference and the EMF, this is for the time and EMF. Now we will take graphical representation for the angle omega t and the EMF. Then for one cycle, to complete one cycle, in time period of t, the angle is of 2 pi, that is 360 degree. Then we can take here this pi, and here will be the pi by 2, and this angle is 3 pi by 2. That is, the current varies from 0 to 20. The angle of rotation of pi is 90 degree, that is pi by 2. Then 180 degree, that is pi. Then 270 degree, that is 3 pi by 2. And then 2 pi. This is the graphical representation. Direction of EMF, or in between EMF and the omega t, that is angle omega t. We know that E is equal to E naught sin omega t. In last chapter of AC generation, we have already discussed or derived this formula of EMF, induced EMF, that is E is equal to E naught sin omega t. And also from this equation we have already derived the formula of I is equal to I naught, then sin omega t plus alpha. I is equal to I naught sin omega t plus alpha. Now this alpha represents the phase difference between the current and EMF. Alpha is the phase difference between current and EMF. And in this case, E naught is the peak value of EMF. Value of EMF, and I naught is the peak value of current. Peak value of current. I naught is the peak value of current. From this graph, we can observe that the EMF or induced EMF varies sinusoidally with respect to time. The value of E is in between or varies from 0 to maximum. At every time the value of E varies in this graph. At this instant, at t is equal to 0, value of EMF is equal to 0. Then of 1/4 of time period, it becomes maximum. Then it again decreases and becomes 0. Then the value of EMF again become maximum or negative. Maximum value of EMF in negative region, and this then become 0. This is one cycle. So here we can say that the graph of E versus omega t. This is the graph of E omega t. It's the graph of omega t. That is, we can say here. Now, from this graph, it can be seen that the direction of EMF is reversed after every half cycle. the direction of EMF. This is the half cycle, and therefore direction of EMF reversed after every half cycle. This cycle again then repeat, and every half cycle the direction of EMF reversed, or it becomes positive to negative, and then negative to positive, again then positive to negative. This type of EMF is called as alternating EMF. Therefore, this type of EMF is called as alternating EMF, because after half cycle the direction of EMF changes, varies, and therefore this is called the alternating EMF. And induced current due to the alternating EMF is called as the alternating current. Therefore, the current due to the alternating EMF is called alternating current, and this is called the AC current. त्यालाच आपण काय म्हणतो, AC current म्हणतो. तर या चॅप्टर मध्ये आपण AC करंटचा स्टडी करणार आहोत. Now we will discuss about the mean value and RMS value of EMF and current. Average and RMS value we will discuss about the average and RMS value. RMS means root mean square value. Now we will discuss about the average or mean value of AC. First item we will discuss about the average or mean value of AC. You can see this point A. We know that the peak value of alternating current or EMF is the maximum value. That is, peak value of current is the maximum value of current, and peak value of EMF means the maximum value of EMF, and the maximum value of EMF is denoted by the E naught, and the peak value or maximum value of current is denoted by the I. Now we will discuss or define the some specific values for comparing two voltage and current waveforms. In this point, the average of all values of voltage over one half cycle. For full cycle, when we take this full cycle, the average value will become 0. For one cycle, the average value will become 0. Therefore, we take a half cycle. The average value of the voltage or current over one half cycle, that is, this is a half cycle. Therefore, average value of EMF or current over a half cycle can be given as average value of sin theta and the value of theta is the range in range 0 degree to pi. For one cycle, the value of theta is 2 pi, and therefore for half cycle, the value of theta is pi, and therefore we will discuss the average value in range 0 to pi, and therefore we can find out the sin theta for average value. Sin theta is equal to, that is, to take average value, we can integrate this sin theta 0 to pi sin theta. For integration, there is a necessity of d theta multiplying d theta divided by integration of d theta. Here we have multiplied by integration of d theta, as well as here we have divided by the d theta. Now the integration of sin theta, we know the mathematical expression, that is integration of sin theta is minus cos theta. We can take limit here 0 to pi, and here the integration of theta is equal to theta. We can take limit 0 to pi. Now we can put the values of integration or limit of integration 0 to pi in this equation. That is, we can take here this minus sign is taken outside this equation. Take upper value, that is cos pi. Pi means 180 degree. Therefore, we can write here cos 180 minus lower value, that is cos 0, divided by pi minus 0. And here the cos 180 is equal to minus 1, and cos 0 is equal to also cos 0 is equal to 1. Therefore, we will get this minus 1. This minus will be taken as remains as minus, and cos 0 is equal to 1, and therefore this part, this will be equal to minus 1, minus 2, minus become a plus 2, therefore pi by 2. Therefore we can say that 2 by pi. Therefore average value of current or EMF is equal to, if we take 2 divided by pi, then we can say the average value of EMF or current is equal to 2 by, that is, we know that I is equal to I naught sin omega t, and or sin theta, I naught sin theta. Therefore we can say the average value of current or EMF is equal to the value of sin theta is 2 by pi, that is 0.637 into peak value, that is peak value. That is, we can say I average is equal to this. I average is equal to 0.637 into peak value, that is R naught. And so we can say E average is equal to 0.637 into peak value of EMF. We get these two equations from this. We have find here the equation of average value of current and the average value of EMF. E, that is I average is equal to 0.637. The 0.637 value of 0.637 is 2 by pi. 2 divided by pi. Value of pi is, take the right here, value of pi, then we get 0.637, and therefore when we put this value in this equation, then I average is equal to I naught sin theta. The value of sin theta is equal to 0.637. Here we can write here 0.637, and therefore I average is equal to 0.637 into peak value of current, and same we will get the E average. E is equal to 0.637 into peak value of EMF, E naught. This is about the average or mean value. This is the average or mean value of EMF and current. Or of AC. Now we will discuss about the root mean square. That is root mean square. That is RMS. Root mean square is RMS value of AC current and EMF. Root mean square means RMS. What is mean of root mean square value? Now we will discuss about a small point. Suppose we take a device, we can take any device, and when we give supply to this device, we can give two types of supply, AC supply and DC supply. First item, we will give a DC supply, AC supply. Then same device is taken, and when we give this DC supply, in DC supply the polarity remains constant. This is the DC supply. We can use battery or cell for the DC supply. Device is same, the resistance of this device is same. When we give a AC supply to a device for a time t second, and when we give DC supply to same device is same, because the resistance of this device is same, and therefore the same device for a time t second. The time of supply is also the same. Then the heat generated or heat produced by the AC supply and heat produced by the DC supply. Heat in AC supply, this will be equal to heat in the DC supply. The heat is same or heat produced is same, time period is same, then this device is same, then heat generator is same. If heat generator is same, then the value of the EMF is called as the RMS value. The value of EMF is called as the RMS value. That is when same quantity of heat can be produced in the same resistance in the same time by passing a steady current of constant magnitude through a device which is equal to heat produced by supplying the AC current for the same timing. Heat produced is same here, and therefore this the value of EMF is called as the RMS value. And the supply, this supply E is called ERMS, and the current produced due to this AC supply is called as the IRMS. तर या ठिकाणी आपण काय केलेलं आहे, एक डिवाइस यूज केलेला आहे. म्हणजे सपोज याचा जो रेजिस्टन्स आहे तो R आहे, याचा रेजिस्टन्स R आहे. दोन्ही एकच डिवाइस आहे, सेम डिवाइस आहे, आणि दोन्हीचा रेजिस्टन्स हा कसा आहे, सेमच आहे. आपण एका सर्किटला AC सप्लाय दिलेला आहे आणि दुसऱ्या रेजिस्टन्सला DC सप्लाय दिलेला आहे. मग ज्यावेळेस आपण AC सप्लाय दिल्यानंतर आपण टाइम किती ठेवला, T सेकंड ठेवला. सपोज 5 मिनिट असेल, 10 मिनिट असेल, इथं पण टाइम कसा आहे, सेमच आहे. तर 5 मिनिट दिला, इथं पण आपण 5 मिनिट टाइमिंग सप्लाय दिला 5 मिनिटासाठी. आणि सेम टायमिंग मध्ये जर सेम हीट प्रोड्यूस होत असेल, तो जो आपण सप्लाय दिलेला आहे AC सप्लाय जो आहे तो जी व्हॅल्यू आहे E ची त्याला ERMS म्हणायचं. The value of E is called as the ERMS value, and the current passing through this circuit is called as the IRMS. This current is called as the IRMS. Therefore, we can say that the alternating current value of or alternating current flowing through the resistance R, let H be the heat produced in time T. Now, same quantity of heat is produced in the same resistance for the same timing by passing the DC current. Of constant magnitude. The value of such a steady current is called as the effective value. This value of the steady current is called as the effective value or virtual value, or we can say the RMS value of given alternating current. This is the RMS value of given alternating current. That is, we can say ERMS, and the current is IRMS. Now we will discuss about these values or formula, or we will compare the peak value and RMS value. Here we will compare the peak value and RMS value, or what is the difference between the peak value and RMS value. Here we know that when we use the AC supply, then the value of AC changes sinusoidally, positive to negative, negative to positive. But at any instant when we take the value of current in the form of square, then it remains the positive value. Therefore, to compare the peak value and RMS value of the AC, we will take a square. Therefore, I square RMS value of AC. And peak Now I square at any instant, I square is a positive, therefore we will take I square. Suppose at any instant the current I square IRMS is equal to this. To find the average IRMS value, we will take a limit for integration, that is 0 to 2 pi for a complete cycle, 0 to 2 pi. The value of I is I d theta. Here we can write in the denominator, that is integration of d theta, and therefore here will be the I square. Now we know that I is equal to I naught sin theta. We know I is equal to I naught sin theta. We can use this equation here, and therefore the 0 to pi, this I naught square sin square theta into d theta. And here when we take the integration of d theta, the integration of d theta is theta, and when we take the limit 0 to 2 pi, then theta is equal to 2 pi minus 0 and will be equal to 2 pi. We can take this 2 pi out of the integration, then we can write here, we can take this I square also out of the integration, therefore sin square theta into d theta. We know that the formula of sin square theta, mathematical formula of sin square theta, that is 1 minus cos 2 theta divided by 2 into d theta. Sin square theta is equal to, this is the mathematical formula, sin square theta is equal to 1 minus cos 2 theta divided by theta. This is the trigonometric equation. You can see this equation in the mathematics book, that is sin square theta is equal to 1 minus cos 2 theta divided by 2. We can take this 2 out of integration, therefore we take here this 2 here. Taking the integration, we can again increase one step, that is 1 minus cos 2 theta into d theta. Now we can take the integration of this equation, that is the integration of 1 with respect to theta, that is the theta, and minus the cos theta, integration of cos theta is sin theta, therefore this minus will be minus, and the integration of cos theta is equal to sin theta, therefore integration of cos 2 theta is equal to sin 2 theta divided by 2, and we can take limit at 0 to 2 pi here. Now we can put the values of here in this equation. I square here into 2 pi will remain same. Theta, taking upper limit, that is theta is equal to 2 pi, therefore 2 pi minus here the sin theta, this 2 will be cancelled and the sin theta will be, upper limit will be taken as the sin 2 pi, and then minus lower limit theta is equal to 0 minus sin theta, that is sin 0. Sin 0 is equal to 0, therefore all terms will be equal to 0, and therefore I naught square divided by 2, and this 2 pi sin 2 pi, that is sin 180, sin 2 pi means sin 360, and sin 360 is equal to 0, and therefore this 2 pi will be cancelled and there will be the I naught square divided by 2. That is, we can say here the I square RMS value of I square is equal to I naught square divided by 2, and therefore this I RMS is equal to I naught divided by root 2. I naught divided by root 2. That is, RMS value of current is equal to peak value of current divided by root 2. If you take the value of root 2, that is 1 upon root 2 is equal to 0.707, and therefore we can write here IRMS is equal to 0.707 into I naught. At any instant, IRMS is equal to 0.707 I naught. The 0.707, it is the value of 1 upon root 2. 1 upon root 2 is equal to 0.707 and into I naught as it is. Therefore, IRMS is equal to 0.707 into I naught. Same as if you take the derivation of ERMS, then we get ERMS is equal to E naught upon root 2, because the equation of E and I are same, that is ERMS and IRMS. Therefore, ERMS is equal to E naught upon root 2, and this value can be written as ERMS is equal to the 1 upon root 2 will be the same value, that is 0.707 E naught. That is, ERMS is equal to 0.707, the peak value of E. These are the equations of ERMS and IRMS. Now, we will discuss about the heat generated that is, the heat is equal to, we know that H is equal to I square RT. I square RT, that is, we can also write the heat is equal to the work done. Heat is the form of work done. Therefore, when we take a integration of I square RT to find the total heat, that is H, we get the H is equal to R into IRMS square. H is equal to R into IRMS square into 2 pi by omega. pi by omega. It is same as the heat produced by DC current of magnitude IRMS for time t is equal to 2 pi by omega. The value of this heat produced is same as the heat produced by the DC current. This is the heat produced by the AC current, and this will be equal to heat produced by the DC current for time t is equal to 2 pi by omega. And this is the root mean square value of AC. Okay, thank you.